Hey everyone, welcome to the VMware Cloud Networking Academy presented by 27 Virtual. In this section, we're going to cover NSX-T business continuity and disaster recovery, presented by yours truly, William Grismore, and Andrew Grismore is with me today as well, NSX-T vExpert. In this session, we're talking about multi-site capabilities brought to us by NSX. NSX has two primary capabilities that would be networking and security. Primarily in this session, we're going to be talking about networking and how it helps us in these multi-site capabilities and what these different scenarios actually are. The first one would be business continuity. One of the best examples would be, I live in an area that could be affected by a hurricane, Florida, for example, and I have a data center in Florida and I have a data center in Los Angeles. What I'd like to be able to do if that hurricane is coming, to be able to proactively take the workload and move it in real time to the other site. So what NSX lets me do from a software-defined networking aspect is it allows me to create tunnel endpoints that live on each host across all my different data centers, which allow me to essentially tunnel network traffic between sites and stretch the network in software that allows the workload to live in site A, which allows me to take that VM and then migrate it to B or C. And I can do so without having to change the IP address, which is a huge feature of having the network defined in software. I don't have to worry about trunking VLANs on the physical side or extending networks and hardware. I can very easily design and deploy these networks in software. One of the main things that makes this work is the NSX-T management cluster. The NSX-T management cluster is deployed, and then from this management cluster, I prep the environment to allow these networks to be stretched. In this case, we can see that we have a single NSX-T management cluster that lives at one particular site. We're going to look at how we can have different scenarios to support multi-site failover, either in a metro scenario or in a situation where I'm in Florida and Los Angeles, and my latency is much greater. And we're going to talk about those different scenarios. The first one would be the DR use case. In this particular use case, we're looking at a metro design. Now, not shown in this picture, we have a single cluster that has been stretched between two sites. And also my storage has been stretched between both sites. Also not shown in this picture, there is a management network that actually stretches here between these two sites that those NSX managers will sit on. So I have my three NSX managers sitting here at this one site, and these managers are plugged into a network that is actually stretched in hardware, OTV, EVPN, whatever it may be, between those sites. So what we have is the basics with NSX-T, which would be a tier 0 gateway and a tier 1 gateway. And the gray router here represents my actual physical router. And you can see that I've established a BGP adjacency so that my networks that live south of my tier 1s get redistributed into BGP. Notice that I have a physical router at the other side as well, but no NSX-T components. Also notice that the VMs on the A side are lit up and running, and the VMs over here are shown as being dimmed out. That just basically means that we have the ability to fail over. So this is kind of a warm site, if you will, where the infrastructure components are ready, the VMs are being replicated, but there's no active VMs running. So this would be like an active-passive type of design. Everything's working. I have all my traffic and workflows functioning. The blue VMs can talk to each other on the same network segment. The light blue VMs can actually talk up through the router, through the tier 0, to the T1, to the dark blue VMs. Not shown in this picture, maybe I have another light blue segment, and one VM on this light blue could go to the router and talk off on this other segment over here that's not shown. So we have full functional switching, routing, all the way east, west, and north, south in the environment. Now, when I lose this primary A site, I'll need some type of mechanism in place to make sure that the VMs that live on the A side can not only fail over, but fail over in a particular order. One of the tools you might choose to use to help you with that would be a VMware Site Recovery Manager. It has recovery plans and recovery groups that you can build to orchestrate the startup order. For example, if I have a 3-tier application, I might want the database to come up first, and then my application tier, and then my front-end web tier. So again, this is a single cluster, vSphere cluster that's been stretched. It's in a metro environment, so within the same metro area where the latency is less than 10 milliseconds. And my storage is also stretched. When I lose the primary site, what makes this a really elegant solution is that everything that I have configured from a routing perspective can fail over automatically, because we're using vSphere HA to fail over these components. Once those components fail over, there'll be a brief outage for north-south traffic as we reestablish these BGP routes and redistribute these routes into the BGP north. And that allows the outside world then to find their way back in again. When this fails on the left, there's going to be a moment in time here when this goes out where those routes are going to drop, and then it's going to fail over. It'll take a few moments for that to be reestablished, and then traffic will start flowing again, just as it did on the other side. And then we use some type of a tool like SRM or whatever it may be you're using, Veeam, Zerto, manual processes you've scripted, whatever it may be, and we can bring those VMs up in the proper order. And then the other thing also that would occur is that these managers here would fail over to the B side as well.
Yeah, in this type of scenario, we are able to get the best of both worlds because we're taking advantage of the ability of the vSphere cluster and the NSX components to be able to allow for the most automated type of failover that we could have in any scenario, all thanks to that stretched cluster. So we're definitely going to rely on HA. We could also be relying on the active passive capabilities that we have in our edges as well. And that's why you can see that it's got that NSX-T automatic recovery, because we shouldn't have to go in and do anything manual to intervene or even need that management plane in the first place in order for this failover to work.
And Andrew, I got a question for you here. So we've done a few of these for customers. In this scenario right here, what actually happens? Is it an entire VM fails over right here to get this up at the other side, or how does this actually work under the hood? Do you have any insight there?
So there's a couple ways that you could do it, but to me, the most efficient way and what we've recommended for our customers is that we actually have an active tier 0 gateway. And it's important to note that when you look at the tier 0 gateway, which is the interaction point between the NSX networks that we have in the physical world, it actually resides inside of an edge, most likely virtual machine. So we're going to have our tier 0 gateway live inside of an active edge in the primary site and actually have the standby edge in which the standby tier 0 gateway lives already living in the secondary site, so that when we do have the failure, we don't even have to rely on HA, because we're going to let NSX-T do its thing, in which it has its own active standby capabilities where we let the tier 0 gateway fail over into the standby. So yes, we're going to lose the active edge VM and HA will bring it up on the other side. But even faster than that is the failover capability that we have built into NSX-T. So we're going to have the failover occur. NSX-T's edge HA will allow for the failover of that edge, the tier 0, to take over in the secondary. At the same time, your virtual machines will be coming up in the secondary site. And before those virtual machines are even ready, we should already have the routes propagated on the secondary site and allow for the north-south traffic to flow over there.
There we go. Very good. So yeah, that's a really good point. I wanted to make sure we pointed that out, because vSphere HA is definitely in play, but there's going to be an edge sitting on both sides of this boundary right here that's shown. And when we fail over, it's not like the tier 0 has to come up as a VM completely from scratch. It's actually just a service that's substantiated in this edge node, and that service just flips on, which makes it very quick. So there is a bit of an outage, but this time it takes for this to flip up to active is pretty quick. And that's why we consider that an automatic recovery. And then once everything's in place and the routes are propagated, SRM, whatever you're doing here to bring the VMs up, and we have our north-south traffic in place. So it's a really good use case. It's very common. We've definitely done a lot of these for customers out there today, and it's definitely something you can implement. And do keep in mind, you do need to have a management network stretched here so that the management plane can fail over. It is important to note, the management plane can be down and all this can fail over and traffic will still flow. So now we're going to switch to the situation where we're in Florida, is our primary site on the A side there that's up. And we have 150 millisecond latency now. And we have Los Angeles, very far away. And we're going to talk about really the same thing. Now, the difference is the way I depicted that just a second ago, instead of having one edge sitting kind of one leg on each side, it's not going to really be like that. Most likely, this is going to be two edges over here. And then we'll have something waiting for us over here on the other side. So it's a little bit different exactly how that works. So let's just put that in place first. So what we're going to do is fail this over. So as I showed there, now this guy right here is two separate, or at least one, they're probably two separate edge nodes, either active standby or ECMP, and it's kind of sitting there waiting as like a placeholder. There's no VMs running, same scenario where the VMs are replicated somehow. Now this is not a stretched cluster because we have Florida data center, we have Los Angeles data center, so it's not stretched. The cluster's not stretched in vSphere, the storage is not stretched. So we're using some type of either array-based replication or vSphere replication works great, or it could be any third-party product you want to use for that. So we have all these kind of components in place. The other thing that's important to note also here before I flip over to the actual failover scenario is the management network could be stretched if you're doing some type of long distance OTV or EVPN. It may be more common though to have a separate network here and a separate network here. So you'd have managers sitting on this side. And then when this site fails, we're going to have standby managers over here. We'll put them in a different color that are ready to go when the site dies. So it's a little bit different from that aspect. So let's go through it. So we're going to do the failure. So I lose my primary site. Again, everything's kind of sitting here waiting. We have all the infrastructure components in place, our tier 0. And we're going to fail over here. And there's a note about this being either a scripted recovery or a manual recovery. Andrew, you want to talk about what's going to happen here if we have the two different networks and we have like the managers? How does that work here?
Yeah, so it's really important to note the difference in the steps for failover in this scenario versus what we saw previously. So in the previous scenario, we had the same tier 0 instance across both the primary and the secondary site. And that active passive type of failover that we had that took advantage of the NSX high availability at the edge level and the vSphere HA at the VM level is not going to be the same here because we actually have an individual tier 0 on the left and an individual tier 0 on the right. And there's no mechanism for active passive between two separate tier 0s. And you'll see that the adjacency that they're establishing, they're both technically up, but the only routes being propagated are on the primary site. If we go back to the pre-failure scenario view here, the routes are originally going to be propagated in the primary, and you'll notice that we actually swing the tier 1 gateways over to the tier 0 in the secondary site, which will then propagate the routes over there. So it's two separate tier 0s that we're looking at. And the step that we're seeing is to move the tier 1 gateways over to this separate tier 0 that's ready and waiting on the other side. The reason to point that out and being specifically different than what we saw before is that we actually have to go to the NSX manager to make a change to tell those tier 1 gateways, hey, you need to plug into the tier 0 that exists in the secondary side. Now, the tier 1 instances and the networks were already stretched all the way across. We just needed that interface to the physical world as you can see, from the green NSX router to the gray physical router over on the other side. And because we have to make that change to the tier 1 and tell it to connect to the new tier 0, we must have the management plane available to us. So we have to make sure that we can fail over that management plane as quickly as possible to our secondary site, which is why we have those standby managers ready to then take the configuration and become the active managers over there, and allow us to make that management plane change to the tier 1 and connect to the new tier 0 on the secondary side. So we've actually done this for customers. You want to talk a little bit about what that scenario is like and just that process, how long it takes?
Yeah, sure. So this process is going to take about 30 minutes. So in this scenario, when we're talking about both these use cases, one term you may hear or may have heard in the current versions of NSX-T 2.4 and 2.5 is something called multi-site Lite. And the reason it's referred to multi-site Lite is because it does support multiple sites. But if you lose the primary site, you have to have this primary site backed up to an SFTP server. You have to have these managers ready to go, and then you have to actually do a restore in this case. And because you're failing over to another site, this is all done by a fully qualified domain name. So we have to actually configure this cluster with a REST API call to put this to say that fully qualified domain names are in use, because by default, the NSX manager cluster and backup is looking for the IP address. So if I don't run this special put command to tell this to use a fully qualified domain name, that means when this fails over, the restore will actually fail, because this is going to have a different IP address, because this is VLAN A on 10.10.10, and this is VLAN B on 10.10.20, and it's a different IP address. So the restore would actually fail. So there's quite a few steps you have to go through here. We have another slide dedicated to that that'll talk about what that is. But the main point that Andrew made that's important is that when I fail over this T1, when I actually fail over, I can't do what this animation is showing right here. I can't actually make that connection until this management plane is up and running. So that can take some time for that to be fully synced. All the services have to be up. There's a list of about 6 primary services there. Those all have to be up and functional. And then I'm able to make that connection and then go back in, because in order to remove this from the old tier 0, it has to be up. And then to add it to the new one, it has to be up. So it does take some time there.
So basically what I'm getting from is that this can be done, but there are some steps that we have to go through to make sure that we can fully understand the process and make sure that we have the ability to actually swing that tier 1 gateway over. And once we have that process down, that's where we can see the scripting start to come into play and make it more of a one-step process or smaller step process than having to do everything manually. The actual step of bringing the tier 1 gateway over to the tier 0 takes about 5 seconds once you're into the NSX manager. We just need to make sure that we can get to that point.
Yeah, but another thing we should point out here real quick also is that you could be in a situation where you have a partial outage, where maybe the management plane is actually still available depending on what the actual problem is. And you could fail over just the T1 component if this was still up and running and available somehow. So if some kind of partial outage, maybe there was some connectivity loss somewhere with a switch or a cable or something, but the management plane was still available, you would be able to make that change. So there's a couple different failover scenarios there as well.
Yep. Also, we're 27 Virtual is based in Florida, and we have many Florida customers. And in a scenario like this, where let's say we know a hurricane is coming, we can preemptively move those tier 1 gateways over as well.
Okay, great. And then the VMs come up, and again, we're using some type of a tool, whether it's vSphere replication, SRM, or some third-party tool to bring those VMs up in order. And then once these networks get connected, we're going to be propagating the routes. One thing I always like to point out on this one also is that if you're really monitoring this, you're going to see in your routing table here that you've lost these routes. So the blue segment and the light blue segment and the dark blue segment, if I look at my routing table, they're going to be gone for a moment. And not until I actually plug this guy back in, which I can't do till the management plane's back up. Once this gets connected, this north-south traffic flow that comes here, this purple arrow, is not going to take place until those routes are propagated so the outside world can find their way back in through the physical to the T1 and down. Then the next one is multi-site active-active, and this could be metro, or it could be long distance. Again, the two different scenarios, again, repeated. This is really good. It shows that no matter where the VM sits in NSX-T, no matter what site that it sits in, if the blue network is connected to this blue, this light blue T1, I'm going to egress out of A. If I'm in A, I egress out of A. If I'm in B, I egress out of A. If I'm on the blue network connected to the blue T1, I'm going to egress out of A. But I can also be active-active, which we haven't shown you yet, where I have a separate tier 0, and I've actually plumbed into it another separate T1. So in this case, if I'm a green VM in site B, I egress out of B. If I'm a green VM in site A, I egress out of B. So if I'm blue, I egress out of A. If I'm green, I egress out of B, no matter what. So some of you may be doing NSX-V, where they support something called local egress. NSX-T doesn't support local egress, but based on our experience and based on VMware's experience as well, there's not a lot of customers that really want to take a VM that lives at the primary site. Let's say the green VMs live here. I mean, if the latency is really that low, you probably don't want to have some of the VMs of an application on one side and the other. You probably have all three VMs together on this side or all three VMs together on this side. Maybe you put the web tier on one side and the app and DB on the other, but it's just not really that feasible. You're not going to see that very often. It's really more about failover, you know, the business continuity or the DR scenario. And then we see the green VMs talking out on the B side. And then another interesting thing you can do here is, let's say that the blue VMs want to talk to the green VMs. The blue VM would have to traverse the T1, the tier 0, go out through the physical. We'd be decapsulated here. A regular TCP packet would get routed however many hops across our data center interconnect over to the other router and in to talk to the green VM, and the same thing back the other way. One little trick you can do to eliminate some hops here, depending on how the network is designed, is you can actually build a tunnel, leverage a tunnel, and have an extra BGP connection between your sites here and do some inter-tier 0 routing. So that way, when the blue VM wants to talk to the green, instead of going all the way out and getting routed across all these hops, we can leave this guy here, the tier 0, the dark blue, and when we leave this interface, the route decision's already been made, and we would go out through the TEP at the host level that does the host-based level encapsulation, and we would route from TEP to TEP. And then we would come in on this side here, whatever host that sits on, and then come back down and talk to the green versus going all the way north-south. It's still somewhat north-south. It's just not quite as far. It's a little bit less of a trek, and it's also encapsulated across.
Yeah, one of the reasons that I really like this active-active scenario, and you'll see that we're going to see it in the metro style first, and this is where you can really start to take advantage of it, because in a metro, you usually aren't going to care too much because your latency is so low, and if you're treating it like one site, if the VMs are spread out like you see here, but it allows you to use both your primary and secondary site resources actively so that you're not in the scenario like we saw earlier where you're treating one side as cold. The beautiful thing here is that you can replicate from one side to the other, and you can have and take advantage of those active, passive on each side setup that allows you to really get the most out of the resources that you have available. On top of that, and what Bill is drawing out there up top, is that management plane What you can do in this specific metro scenario to even further protect yourself is deploy 2 of the managers on one side in your primary, 1 of the managers on the other, and again, let high availability take care of the recovery of the management plane, because again, the network is stretched, you don't have to change anything with them, and let HA and that metro take care of the recovery of those managers, and now your management plane is reestablished and you can continue to go on as you were before. So a really cool scenario here that I think most customers really want to take advantage of. And if you're worried about where traffic is going in and out, all you have to do is make sure that your virtual machines are plugged into the appropriate network and live in the appropriate site, and you'll get that egress where you want it to be.
So once I lose that primary site, because this is that, again, we're in the metro design here, it's an active metro. So what that means is we have, again, a stretched vSphere cluster, we have stretched storage. We're able to fail over the tier 0 over to the other site and instantiate those routing services here. We can maintain this BGP interlink here and go north-south. This was already established. We're basically connecting this northbound, and we're keeping this established to get that traffic to move the way we need it to. So it's a very elegant solution. And then again, the management plane, I already had the one there. If we do it the way I had it drawn, then I just have to wait for the other 2 to substantiate themselves here. And again, it's an automatic recovery, and then the VMs are gonna come back up. Same considerations, there might be some considerations about what VM starts in what order. And then the purple just shows again that we have both east-west traffic flows across, again, the blue going up and across. And it's interesting, even though they're in the same site, we still have to go on this little bit of a road trip where we go up, we go over, we go up, we come up, we come over here to this green, down to the green and in. So that flow still takes place, but we're maintaining both the east-west and we're maintaining the north-south. This slide here is all about the management plane. So this is the automatic recovery. So this is where we have some steps involved to be able to recover. So in this situation, if it's a metro and it's automatic recovery, we have a VLAN stretch network. So we're using some type of technology here to stretch this, whether it's spanning tree or whether it's, no, don't do that. Whether it's spanning tree or OTV or EVPN or some other layer 2 hardware stretch technology. And some people might say, well, I thought we're trying to do software-defined networking. Well, that's still true, but we're only configuring this hardware stretch one time. It's a one-time setting. After we put this one piece in place, everything else from then on is software-defined, and we're able to fail over those managers. In this case, all we're worried about is the IP address. I don't have to worry about setting or putting the managers to leverage a DNS FQDN name. Everybody just knows them by IP address. So if there's an outage at one site, you know, we can fail it over to the other site. We always still make sure it's backed up no matter what. If we lose this primary site, again, it's a stretched cluster, stretched storage. We can bring that management plane up at the other site and keep things going. And there could also be that scenario where we have 2 sitting on A and 1 sitting on B, which is not shown in this picture. And I'm using vSphere HA. So this is a regular vSphere HA, and we're waiting whatever it takes for those VMs to come up, whether it's 2 minutes or 5 minutes, depending on your exact configuration. Okay, so for this part right here, we're moving over to a situation where we have Florida and we have Los Angeles. So we no longer have a stretched cluster. We no longer have stretched storage. I'm using the regular multi-site Lite, if you will, feature. We're going to talk about Federation in just a minute. And my latency is 150 milliseconds or less, greater than 10. And what we're going to do is make sure that we have a network plumbed on both sides, 2 different networks. We're not stretching the network. Now, You could, in theory, stretch the layer 2 all the way across and do like on the previous slide, but you're still going to have some way to recover the management plane. You wouldn't have to worry about the DNS scenario. You could keep the IP addresses if the layer 2 is stretched, but you still have to have a way to bring those guys back up. So in this situation, what we're saying is we have one network on this side, one VLAN, 192.168.1. And on this side, we have another VLAN, 192.168.2. So that's important to note right there. We have entries in DNS. We have our A records and we have our PTR records in DNS. It's very important that your records have a very short time to live. 5 minutes or less is recommended. We've done some for customers as low as 30 seconds. And what you have to do when you set this up is you have to make sure that you configure this cluster to use fully qualified domain names. So there's a REST API call to put this to set that. Once you do that, you start doing your backups. You make sure you have your DNS entries with the low time to live. And remember, our entries look at the third octet. That's that .1. And everybody's leveraging a fully qualified domain name right now. They're not finding the management cluster by IP address anymore, which is very, very important. DNS is very, very important in this configuration. We're going to pre-stage this cluster over here on this network. So this is going to be on the 192.168.2 network. We can deploy 1 or we can deploy 3. We pre-stage them, we deploy the OVA, we give it an IP address, we stop right there. We don't actually form the cluster, and we make sure that we're doing our SFTP backups to the other site. I can deploy just 1 and recover, deploy the other 2, or I can deploy all 3, recover 1, and join the other 2 to the cluster. When I lose this site with everything in place, now what I do is when this guy dies, I'm going to modify my DNS entries. So I'm going to modify my A records. Remember, I have a very short time to live, so that's going to time out across all my hosts and from the management plane. I'm going to restore the backup to this specific appliance, join the other 2 to the cluster, and then make sure that my hosts, my transport nodes, connect and see the new cluster. And then my management plane is back up and running. And then in that previous slide where we saw how we got to reconnect the T1 and link it to the uplinked tier 0, now that step will be available to me. Now it's time to talk about NSX Federation. So in NSX 3.0, we have a brand new feature. Everybody's talking about it. And it's very interesting what it's going to do. It will allow you to solve this problem that we're talking about where we have to do this failover of the management plane in this multi-site Lite. So basically take all of this complexity and just kind of throw it away. You don't have to worry about it anymore. And Federation solves that for us. And what we do is we treat each data center as a separate location. And this data center could have multiple vCenters potentially. And I'm going to deploy 3 managers that are considered local managers at each one of these locations, A, B, and C. So 3 separate local managers. And then we're going to have at the top something called a global manager. And it's going to allow us to have a consistent configuration and a consistent security deployment across multiple locations. The current version that we have right now will support up to 4 different locations. So it ensures high availability of the applications by having consistent networking and security, better application response time, especially in failover scenarios, a very cost-effective hosting solution. And what we mean by that is this could be your on-prem data center. This could be VMware Cloud on AWS. This could be IBM Cloud. And we can have a consistent networking and security across all of these. What if I purchase a company? I decide to go out and buy ABC company and they're completely disparate. They can have a separate set of NSX managers and then I can federate them into my environment. So there's a lot of really interesting use cases around federation. So what does it give us? Operational simplicity. So by having that global manager and consistent configuration, think about it from a security perspective, even though this session is not really about security, but if I have all these different data centers and all these different locations with separate local managers and a global manager, all in a single UI, I can make a change to implement security across multiple sites and push those policies and configurations down globally. It definitely makes things easier. And then if there's an outage at one of these locations, I'll have a standby set of managers at another site to immediately take over. It's almost like a one-click failover versus many, many steps as we saw in that previous slide at the end of the multi-site Lite presentation. It should be noted, you still can do multi-site Lite. And one thing I want to point out as we go forward is that if you don't do Federation and you have just 3 managers, let's be very clear, you can still do that if you choose to. And if I have 3 managers across just, controlling all 3 sites, three sites with the one set of 3 managers, I can have a stretched tier 0, I can have a stretched tier 1, and I can have stretched network segments. I can do that. If I go to the idea of having local managers and a global manager, it's going to change quite a bit. What I'm going to do instead is have my local managers, my 3 at each location, and I'm going to have a set of local objects that will not stretch as they do currently. If I want things to stretch, then I'm going to build an other set of T0s and T1s that do stretch across those multiple sites. So it's kind of a different way of doing it. And you could still do it the old way if you choose to, depending on your use case, or you could definitely go with the new way with Federation. So you can definitely go either way with it. I do think over time, due to the complexities of the failover of the management plane and multi-site Lite, that we'll probably just see everybody adopting this as the way going forward. But there could be some situations as we transition from one method to the other where we might make some other decisions there. The other thing that's really cool about this is that it's a single pane of glass. I can log into one interface in the NSX Manager H5 interface, and I can see both sides. I have REST API available, infrastructure as code, if you will, where we can automate these global processes. Imagine if you're a service provider, you have multi-tenancy. There's a lot of really cool things that it brings. So these are the components. You're going to have a global manager cluster that's going to be deployed. The global manager can be configured to span multiple locations or a single location. Any global configuration is pushed to the relevant local managers. It's kind of like a 2-tier structure. I do a global configuration. It pushes it down to the local managers. And then the local managers are the ones that actually substantiate the change at the host level. Any configuration that needs protection against location failures must be configured in the global manager. So anything that I'm intending to support across multiple sites would be a global manager configuration. We're no longer going to be using the local managers to have stretched tier 0s or stretched T1s. Unless we look at it from a data center perspective, you could have a fairly large data center and my local managers might be stretching across racks. Let's say one rack reaches some type of vCenter limit, I could hit that potentially. And still my local managers could be doing some stretching across multiple rows or racks within a local data center. So these guys here still play a very, very important role. And depending on my use cases, I might have a mix of some local and some global. And they still all the core prep. The same prep we did before with the managers, they still do that prep. They're going to create our transport nodes, our edge nodes, our transport zones, our IP pools, and so on. And here's all the different components. So we have the global manager and the local manager deployed in the form of a VM. So it's an appliance just like we're used to. The global manager node does not include the control plane. That's still going to be managed locally. The local managers is deployed as a cluster in each location for high availability. And there are some settings where a local manager can actually override a global manager setting. And we're starting to run out of time. One thing here I wanted to point out that I think is fairly interesting is that you can configure one of your locations to be your primary site where traffic's going to flow north-south, and traffic from the other 2 sites is going to go east-west and egress out of that one site. The other option we have is each site becomes active. And the thing that's interesting here that I want to just throw in is that we can actually have, or we would have, edge nodes that reside at each one of these sites. And if I want a network to stretch from the global manager configuration across all the sites, there's a new feature here that we take advantage of where we build tunnels across these edge nodes. There can be different multiple tunnels established. So just like we have now in NSX-V where we have a VTEP, or in T we have a TEP that lives at the host level to control VM to VM communication, we still have these TEPs for host-to-host based tunneling. But something that we have new is something called an RTEP. And the RTEP allows us to build the tunnels from edge node to edge node. So it's a similar concept, it's just at a higher level. So if I have VMs that live down in one site, and they want to talk all the way to the site C, location 3 on the right, the traffic flow is going to go from VM to TEP. It's going to leave the edge node. We're going to leverage this RTEP to RTEP tunnel. It's going to come in from the RTEP on the right, be received, passed down to the TEP to wherever the VM lives, and delivered to the VM. So there's a couple different interesting scenarios here when we actually build and establish the federation. Thanks for joining this session. We'll see you guys in the next video.